Okay, for our final example then, we're going to look at the example of producing calcium chloride. So we've got the reaction of calcium as a solid reacting with chlorine to produce CaCl2 as a solid. So we've got an enthalpy of formation there with a value of minus 795. As always, I'm going to take the time to go through each of the steps of writing out my equation. I'm doing this to build my confidence. Okay, by the time you're in an exam, you might not need to go through all of these steps, but use the example of when you first started to balance equations. You had to write down every single side how many atoms were on the reactants and products side. At this point, you don't need to do that, but you're building your confidence by practicing each of those steps. So the first thing I'm going to do is take my calcium solid and turn it into calcium in its gaseous form. So that would be my enthalpy of atomization, which has a value of minus 795. I'm then going to take that calcium, which is now a gas, and I'm going to turn it into calcium 2 plus as a gas and 2 electrons. Now if you look at the question, if you look at the information we've been given in the question, we're told that the enthalpy of ionization, and this would be the second ionization and the first ionization energy together, is 1730 kilojoules per mole. So we're told that in the question. We can write that straight in. The next thing we're going to need to do, even though we are using both of those chlorines to make CaCl2, I still need to break them apart. So we're still going to need the bond dissociation energy. So we're going to have chlorine 2 as a gas, turning into 2 chlorine atoms as a gas. Now, if you look at the question here, we've been given half of that. We've been told about taking half a chlorine molecule and turning it into 1 chlorine atom. So they've given me the bond dissociation energy here as 121, but because I've got 2 atoms of chlorine, I am going to have to multiply that by 2. The next step then is going to be to take those 2 atoms of chlorine and turn them into 2 chloride ions using 2 electrons. Forgot to put them on. Now this is what we're going to try and work out, the electron affinity. So we're going to keep that blank. And then our final step here is going to be taking our Ca2 plus. Let's find my state symbols on. And my 2 Cl minuses as a gas. And producing my CaCl2 as a solid, which we're told has a lattice enthalpy of minus 2184. So I've got that bit. I can start to now put together my Haber cycle. So across the bottom, I'm going to have my product, which is CaCl2. I've then got my enthalpy of formation. So I've gone from calcium as a solid plus chlorine as a gas, which has an enthalpy of formation of minus 795, making sure my arrows are pointing in the right direction. My next step is going to be taking my calcium and turning it into a gas, which is the enthalpy of atomization, which we now have a value of minus 795. Oh, no, it doesn't. Oh, I've put a wrong number somewhere. This should not be minus 795. This should be 190. And then this should be, the rest look correct. My apologies. So this should not be 795, this should be 190. I've then gone from Ca to my Ca2 plus as a gas and Cl2 as a gas. I've now got my 2 electrons as well, which has a value of 1730. And then I've gone to break apart my bond dissociation here. So I'm taking my Cl2 and making it as 2 Cls. So I've got Ca2 plus as a gas, plus my 2 electrons, plus 2 Cl atoms. Remembering that I just worked out it was 121 times 2, so it's going to be 242. That took a lot longer than I'm proud to admit. And then on the right hand side, I've got my enthalpy of electron affinity, which is what I'm going to try and work out in a moment. And I've got my, which is going to produce my 2 Cl minuses as a gas, and my Ca2 pluses as a gas, which is then going to have, it's then going to turn into my CaCl2 as a solid, and we'll have an enthalpy change. So the enthalpy of, which is going to be, lost it, where am I? Minus 2,184 kilojoules. So I can work out the left hand side. So on the left hand side, I'm going to turn this one around, plus 795. So I'm going to have plus 795, 190, 1730, 242, which gives me 2957. So on the right hand side, I'm now going to subtract 2,184 from that, which gives me 773. However, okay, we cannot stop there. You'll be forgiven for thinking immediately that is our final answer. But if we take a moment and just go back to our definition of electron affinity, so the enthalpy change of electron affinity, it's the standard enthalpy change when a mole of gaseous atoms is converted to a mole of gaseous ions. Well, what we've got is 2 moles of gaseous atoms to make 2 moles of gaseous ions. So this value is the value for 2 moles. The standard electron affinity should be for 1 mole. So I must divide that answer by 2. Will give me 386.5 is an electron affinity, so it must be minus kilojoules per mole. Well done if you got all the way to that point and that was the only step you missed.